Hello and welcome to the first lesson of Unit 5, Sampling Distribution of Means. So let's first define some vocabs. What is parameter? It is a number that describes a population. A parameter is a fixed value, but in practice, we don't know what it is, because we cannot measure the entire population, which is also census. We will have to use a sample to estimate the population parameter. Statistic. It is a number that describes a sample. The value of a statistic is known once we take the sample. But in practice, our statistics will change from sample to sample. The sampling distribution of a statistic tells us how we can expect our statistic to vary from sample to sample. A sampling distribution of a statistic is the distribution of all possible values, taken by the statistic in all possible samples of the same size from the same population. A statistic is unbiased if the mean of its sampling distribution equal to the mean of population. We will always be sure to take a simple random sample of our population. This is how we ensure that our statistic is unbiased. The variability of statistic is measured and described by separate of its sampling distribution. Not separate, but spread. In our case, we will use the standard deviation of the statistic as our measure of spread. So here are a couple notations you'll see frequently. Those are for populations and those are for samples. So this is for the means, this is proportions, this is standard deviation, and this one I'm not really sure, but we'll get into that later on. So this is basically how visualizing the normal curve. So this is for the population and this is for the proportion. No, this is for the sample means and this is for the sample proportions. So you can see if I want to draw all of those sample means together to put them on a population means normal curve, then all of those curves, like the area under the curve, are composed by a lot of sample means. And for the proportions, I put all of the sample proportions together under the curve to compose a population proportion. So that's how you visualize what does each normal curve represent. So moving on to the sampling distribution of a sample mean. Imagine a population of 5 people. So the day's skating was recorded down here. So Andrew skied one time, and Banks skied 5 times, Chester skied 5 times, David skied 5 times, and Eleanor skied 9 times. So if I want to draw put down the sample means onto the curve, I get a sampling distribution. So now imagine that for some reason you cannot measure the entire population, but you can select a random sample of size 2 to estimate the entire population. For samples of size n equal to 2, the sampling distribution of the sample mean x bar could be constructed as follows. So we're only using n equal to 2, and this is the possible samples, and this is the x bar represent for each. So how many combinations do we have? Well, we can use our calculator to help us to do it. Since we have 2 out of 5, for us to manipulate the combination, then the total combination will be 10, and that's how I got the possible samples right here. And I'm gonna plug in all of those values onto my curve, normal curve. And you can see that as we increase our sample size, the spread is less. The center is the same, but it's more normal. So increase the sample size will definitely let your data become more normal and closer to the real mean. And means. The analysis leads us towards formulas for the mean and the standard deviation of the sampling distribution of the sample mean. Consider a population with mean equal to mu, standard deviation equal to delta. The sampling distribution of the sample mean, x bar, that is to say our distribution of possible x bar values when we sample with size n, will have mean equal to mu and standard deviation equal to delta divided by square root of n. So you can see as n gets larger, the normal curve will become more skinnier and more closer to the center and will become higher. And this is the standard deviation of x bar. You're going to label it always next to the curve. So there are your measure of center and spread. What about shape? The shape of your sampling distribution will be normal if at least one of the following is true. First, the population is normal. Second, your sample size, n, is sufficiently large, say greater than 25 or so. Some books say greater than 30. It depends on your textbook or your professor, but as n gets large enough, even though the original shape of the population is not normal, it will become normal once your sample size is large enough. And this is also known as central limit theorem. And why do we like normal? Because we can use normal CDF, inverse norm, and Z tables. So there's a lot of tools to help us analyze our curve. So that's definitely a good thing. Okay, so here's the link, but I won't click it. It's just a stat book. So that's all for this video, and I hope it gives you a general picture of sampling distribution and a great video to open the scene for Unit 5. And thank you so much for watching.